To look at how we can convert the base of an exponential function into any base we like. In other words, we want to manipulate the base, which we're denoting as b, and still get a given value of y. So if we take our exponential function, okay, which has been rewritten down here, and as you can see, this here can be rewritten as follows. Because of our rules of exponents, we know that b raised to the power of c, all in brackets, and then raised to the power of t will give us the same answer as b raised to the power of c times t. In other words, if we see an exponential function in this format, we need to multiply c by t. All right, so this numerical example, or these two numerical examples down here, are going to show us how we can change the base of our exponential function and still get the same answer for y. So if we take these values for a, b, t, and c and plug them into our exponential function, we will end up with y equals 3 to the power of c times t, which we can also rewrite as follows. C is 2 and t is 2. And because of our rule that we discussed above, we know that we would multiply 2 by 2. We would have y equal to 3 raised to the power of 4, which is 81. So we're getting a value for y of 81 from a base of 3. In this example now, we are changing the value of b, the base, to 9, and c will be 1 now. So by changing the base, we will see that we can still get the same value for y. 3 squared gives us 9, and 9 to the power of 1 gives us 9. So just through some manipulation of the base, we are able to get to the same final answer for y. If we plug all these values into our exponential function here, we will end up with 9 raised to the power of t. If we rewrite that, it would be 9 raised to the power of 1, which is now the value of c. And then out here we would have 2, which is our value for t. Okay, 1 times 2, we would end up with 9 squared, and we see we get the same value for y. It's 81, but from a base of 9. All right, so this just illustrates or shows how we can get the same value for y from different bases. All right, so looking at this exponential function, we have been working with b, the base, and t, the variable, but we also have a and c here, and we'd like to know what happens to the exponential function, and specifically we're going to look at the graph of the function when the values of a and c change. And what we will see is that a and c are compressing or extending agents. In other words, when their values change, this will change the position of the exponential curve. Looking at this slide, we show what happens to the position of the exponential graph when we change the value of c and a. All right, so we're still working with this exponential function here, and we have kept the base the same for all of these functions. So the base is, there's the base there, set at 2. Okay, and all that we change on the left-hand side is the value of c, and on the right-hand side we change the value of a. So if we look at changing the value of c, all right, for this exponential function, the value of c is 2, and here the value of c would be 1, all right? And we have shown different values for x down here, and if we plug these into the exponential functions shown above, for y and z, we can see the different values that we get, and these two exponential functions have been graphed. So this is the y function, this blue line here, and the brown one is the z function. And what we can see is when the value of c increases, right, what it is effectively doing, it's compressing the exponential curve towards the y-axis. Okay, if you were to halve the value of c, then this would extend the curve away from the y-axis. Okay, if we look at this side here, we are changing the value of a, okay, a being the value that the base is multiplied by. Here it would be, here it is 2, and here it is 1, right? And again, we have indicated values for x, plug these into the above exponential functions, and we've calculated y and z, and plotted these two curves. Y is the blue line, z is the brown line, and what we are seeing here is that as the value of a increases, it also serves to compress the exponential curve towards the y-axis.